Okay, welcome back. This is example G for solving AV or absolute value inequalities. These are the special cases. So example G is going to look at what do you do when you're taking the absolute value of a number and looking for the absolute value of a number that's greater than zero. So in this situation, this is anytime you have greater than zero, this is what we call the OR condition. And so we're going to consider two cases, just like we did in all the other examples, what happens here. So on the left side, we're going to say that x is, or the absolute value of x minus 3 is less than 0. And then our other side of the OR is going to be x minus 3 is greater than 0. So as long as it's true on one side or the other, then we are going to be fine. So we're going to say by adding 3 to both sides on both inequalities here, we can say that x is less than 3 or x is greater than 3. And so what we can do is we can pick two values to test that condition. So we're going to let x be 2. That's less than 3. And over here, we're going to let x be 4. So now we just take the absolute value of 2 minus 3 and we ask, is that more than 0? 2 minus 3 is -1. The absolute value of -1 is 1. 1 is greater than 0. So that is a true case there, or true solution set. Over here, we have the absolute value of 4 minus 3. Is that greater than 0? Well, 4 minus 3 is 1. Absolute value of 1 is 1. 1 is greater than 0. So this satisfies the condition as well. So our solution set can be written down as x is less than 3, or, sorry, that should have been the u, x is greater than 3. Say, or we can just also simplify this by saying that x cannot equal 3 in this case. Okay, if we let x equal 3, then we would get the absolute value of 3 minus 3, which is not greater than 0. It would be 0 is greater than 0, and that's just not a true statement. So we would not allow x to work for this one. On the number line, you can see it like this. You can say, well, we can take the only number we had was 3, so we just picked 3 on the number line, and we say, well, it's an open point. We can take all the values left that are less than 3, so this is x is less than 3. All the numbers to the right, that would be x is greater than 3. The only one that we could not use was 3 itself. Okay, so which is why we can say that x does not equal 3. All other numbers will work. So with that, this helps us write a definition for our special case when the absolute value of a number is greater than 0. What are we able to do? In this situation, the absolute value of x is going to always be greater than 0 for all x values that are not equal to 0 in this case. Okay, keep in mind, in our case, we were adding or subtracting 3. So we had to find all values that are not equal to 3. Okay, so for this generic case, the solution set is going to be x less than 0 or x greater than 0, or we can write it down as x cannot equal 0.